Today in this video we're going to learn about a formula that allows us to find the area of a polygon inside a coordinate plane. And this formula can help us find the area of any type of polygon, whether it be a regular polygon or an irregular polygon. The formula is known as the Shoelace formula and it looks like this. The only condition to use this formula is that the coordinates of all the vertices of the polygon must be known. Now let's look at a couple of examples. In this first example, I need to find the area of the triangle whose vertices are -3, 4, 1, -2 and 5, 5. In order to use this formula, I don't need to imagine how the triangle looks like. I only need to know the coordinates of the vertices. And in order to use this formula, the first step would be to name my coordinates. I can start with any one coordinate and name it as x1, y1. The next I'm going to name as x2, y2 and this as x3, y3. The formula says that the area A is equal to 1 upon 2 times modulus and then the first coordinate x1, y1, then x2, y2, then x3, y3. Now after writing all the points, I'm going to rewrite the first point, which was x1, y1 and then modulus close. So this is my formula for the area of this triangle. For the next step, I'm going to substitute these values inside this formula. So the area would be equal to 1 upon 2 times modulus. x1 is -3 and y1 is 4. x2 is 1 and y2 is -2. x3 is 5 and y3 is 5. And then x1, y1. x1 is -3 and y1 is 4. Now for the next step, I'm going to multiply my numbers in this diagonal with each other. So 3 is going to get multiplied by -2, 1 is going to get multiplied by 5 and 5 is going to get multiplied by 4. So it's going to be area is equal to 1 upon 2 times modulus and -3 times -2 is +6. Then 1 times 5 is 5, so plus 5. And then 5 times 4 is 20, so plus 20. Now after multiplying the numbers in this diagonal, I am going to multiply the numbers in the other diagonal. So 4 is going to get multiplied by 1, -2 is going to get multiplied by 5, and 5 is going to get multiplied by -3. 4 times 1 is 4, so 4, and then -2 times 5 is -10, and then 5 times -3 is -15. And then modulus close. And in between these two brackets, there is going to be a minus sign. Now let's simplify this. 6 plus 5 plus 20 is going to be 31. So the area is equal to 1 upon 2 of 31. And then 4 minus 10 minus 15 is -21. So minus times -21. And then modulus close. Minus times -21 is going to be +21. So the area is going to be equal to 1/2 times modulus 31 plus 21. 31 plus 21 is 52 and the modulus of +52 is just 52. So the area would be equal to 1 upon 2 times 52. And this comes out to be 26. So the area is equal to 26 units squared. This is the area of the triangle whose vertices are this. And so this is my answer. In the next example, I need to find the area of the quadrilateral whose vertices are -2, 7, 6, 9, 4, 5 and 0, 3. I am going to find the area of this quadrilateral by again using the shoelace method, and for that I need to first name my coordinates. I can start with any coordinate and name it as x1, y1. I'm going to start with this, so this is going to be x1, y1. I'm going to name this as x2, y2, this as x3y3, and this as x4y4. Now I'll use the formula. The formula is that the area is equal to 1 upon 2 times modulus and then x1 y1. x1 is minus 2 and y1 is 7. So I'm going to write minus 2 and then 7. The next coordinate is 6 and 9. So 6 and 9 here. Then 4 and 5. And then the last point is 0, 3. After writing all the points, I'm going to rewrite my first point, which was minus 2, 7. And now modulus close. Next, I'm going to multiply the numbers in this diagonal. So then the area is going to be equal to 1 upon 2 times modulus and then minus 2 times 9, which is minus 18, 6 times 5, which is 30, 4 times 3, which is 12, and then 0 times 7, which is just 0. Then next, I'm going to multiply the numbers in this diagonal. So 7 times 6 is 42, and then 9 times 4 is 36, so plus 36, 5 times 0 is 0, and then 3 times minus 2 is minus 6. And remember, there is a minus sign between these two brackets. Minus 18 plus 30 plus 12 is 24, and 42 plus 36 minus 6 is 72. So this would be area is equal to 1 upon 2 modulus of 24 minus 72. 24 minus 72 is 48. So this would be area is equal to 1/2 times modulus of minus 48. The modulus of a negative number is a positive number. So this would be area is equal to 1/2 times positive 48. 1 upon 2 times 48 is 24. So the area is equal to 24 units squared. This is the area of this quadrilateral. This is my answer.